The Apple II is an 8-bit home computer, one of the first highly successful mass-produced microcomputer products, designed primarily by Steve Wozniak, manufactured by Apple Computer and introduced in 1977. It is the first model in a series of computers which were produced until Apple IIe production ceased in November 1993. History: the earliest Apple IIes were assembled in Silicon Valley, and later in Texas. Printed circuit boards were manufactured in Ireland and Singapore. The first computers went on sale on June 10, 1977 with a MOS Technology 6502 microprocessor running at 1 MHz, 2 game paddles, 4 KB of RAM, an audio cassette interface for loading programs and storing data, and the integer basic programming language built into the ROMs. The video controller displayed 24 lines by 40 columns of monochrome, uppercase-only text on the screen, with NTSC composite video output suitable for display on a TV monitor, or on a regular TV set by way of a separate RF modulator. The original retail price of the computer was $1,298 USD and $2,638 USD. To reflect the computer's color graphics capability, the Apple logo on the casing was represented using rainbow stripes, which remained a part of Apple's corporate logo until early 1998. Overview: in the May 1977 Byte, Steve Wozniak published a detailed description of his design. The article began, "To me, a personal computer should be small, reliable, convenient to use and inexpensive." The original Apple II used data cassette storage like other microcomputers of the time. In 1978 they introduced an external 5 1/4-inch floppy disk drive, the Disk II, attached via a controller card that plugged into one of the computer's expansion slots, which was used for data storage and retrieval to replace cassettes. The Disk II interface, created by Wozniak, was regarded as an engineering masterpiece for its economy of electronic components. The approach taken in the Disk II controller was typical of Wozniak's designs. The Apple II used several engineering shortcuts to save hardware and reduce costs. For example, taking advantage of the way that 6502 instructions only access memory every other clock cycle, the video generation circuitry's memory access on the otherwise unused cycles avoided memory contention issues and also eliminated the need for a separate refresh circuit for the DRAM chips. Rather than use a complex analog-to-digital circuit to read the outputs of the game controller, Wozniak used a simple timer circuit whose period was proportional to the resistance of the game controller, and used a software loop to measure the timer. The text and graphics screens had a complex arrangement which was reputedly due to Wozniak's realization that doing it that way would save a chip. It was less expensive to have software calculate or look up the address of the required scan line than to include the extra hardware. Similarly, in the high-resolution graphics mode, color was determined by pixel position and could thus be implemented in software, saving Wozniak the chips needed to convert bit patterns to colors. This also allowed for sub-pixel font rendering since orange and blue pixels appeared half a pixel width farther to the right on the screen than green and purple pixels. Display and graphics, color on the Apple II series took advantage of a quirk of the NTSC television signal standard, which made color display relatively easy and inexpensive to implement. The original NTSC television signal specification was black and white. Color was tacked on later by adding a 3.58 MHz subcarrier signal that was partially ignored by B&W TV sets. Color is encoded based on the phase of this signal in relation to a reference color burst signal. The result is that the position, size, and intensity of a series of pulses define color information. These pulses can translate into pixels on the computer screen, with the possibility of exploiting composite artifact colors. The Apple II display provided 2 pixels per subcarrier cycle. When the color burst reference signal was turned on and the computer attached to a color display, it could display green by showing one alternating pattern of pixels, magenta with an opposite pattern of alternating pixels, and white by placing 2 pixels next to each other. Later, blue and orange became available by tweaking the offset of the pixels by half a pixel width in relation to the color burst signal. The high-resolution display offered more colors simply by compressing more, narrower pixels into each subcarrier cycle. The coarse, low-resolution graphics display mode worked differently, as it could output a pattern of dots per pixel to offer more color options. These patterns were stored in the character generator ROM and replaced the text character bit patterns when the computer was switched to low-res graphics mode. The text mode and low-res graphics mode used the same memory region and the same circuitry was used for both. Sound: rather than having a dedicated sound synthesis chip, the Apple II had a toggle circuit that could only emit a click through a built-in speaker or a line-out jack. All other sounds were generated entirely by software that clicked the speaker at just the right times. It was nearly a decade before an Apple II was released with a dedicated sound chip. Similar techniques were used for cassette storage. The cassette output worked the same as the speaker, and the input was a simple zero-crossing detector that served as a relatively crude audio digitizer. Routines in the ROM were used to encode and decode data in frequency shift keying for the cassette. Third-party devices and applications: Wozniak's open design and the Apple II's multiple expansion slots permitted a wide variety of third-party devices, including Apple II peripheral cards such as serial controllers, display controllers, memory boards, hard disks, networking components, and real-time clocks. There were plug-in expansion cards such as the Z80 card that permitted the Apple to use the Z80 processor and run a multitude of programs developed under the CP/M operating system, including the DBase2 database and the WordStar word processor. There was also a third-party 6809 card that would allow OS 9 Level 1 to be run. Third-party sound cards greatly improved audio capabilities, allowing simple music synthesis and text-to-speech functions. Eventually, Apple II accelerator cards were created to double or quadruple the computer's speed. Power source: Rod Holt is credited with the solution. Holt employed a switched-mode power supply design. This generated far less unwanted heat than a linear power supply, which some other home computers still used. Isaacson quotes Wozniak saying that this was not something he could have done. "I only knew vaguely what a switching power supply was." Reception: after seeing a crude, wire-wrapped prototype demonstrated by Steve Wozniak and Steve Jobs in November 1976, Byte predicted in April 1977 that the Apple II may be the first product to fully qualify as the appliance computer. A completed system which is purchased off the retail shelf, taken home, plugged in and used. The computer's color graphics capability especially impressed the magazine. The magazine published a favorable review of the computer in March 1978, concluding that for the user that wants color graphics, the Apple II is the only practical choice available in the appliance computer class. Personal Computer World in August 1978 also cited the color capability as a strength, stating that the prime reason that anyone buys an Apple II must surely be for the color graphics. While mentioning the oddity of the artifact colors that produced output that is not always what one wishes to do, it noted that no one has color graphics like this at this sort of price. The magazine praised the sophisticated monitor software, user expandability, and comprehensive documentation, and concluded that the Apple II is a very promising machine, which would be even more of a temptation were its price slightly lower. For the moment, color is in Apple II. See also: Apple II series, Apple I, Apple III, Open Emulator, an emulator of the Apple II, references.